Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, dear students. Welcome back in lecture 6. Student, basically lecture number 5 we covered this table and I will show you how to check these movements basically in Excel sheet. Okay. Now in this lecture inshallah I will discuss a little bit detailing of the slab, and then I will discuss about the design of beam. Okay, so here you see that we have, I already explained this in lecture number 5. We have wall, okay, and we have a flexion member. Okay, so here you see we have cut up bars. Okay, and in this diagram you see here we have bent up bars. Okay, so to understand these bent up bars, let me show you a video. Okay, here you see basically in this animation that we have bent up bars. Okay, this is slab and this bent up bars in one way direction. Let's see that how they place the bent up bars in other direction, and similarly in this video you will see that how they place basically the torsional reinforcement. Okay, so this is the other way bars. You see one bar is straight, the other bar is bent up. One bar is straight, the other bar is bent up. In this animation you see that this is bent up bar. Okay, two-way bent up bar. Sometime they basically bent this side and keeping this side straight. Then the other bar which is adjacent to this bent up bar, it's this end should bend up while the other end is straight. Okay, so that is called, we can say, alternate bent up bars. Okay, here you see basically one straight up bar and the other bar, two sides are bent up. Okay, so this different configuration is possible. Okay, we can bend up bars in different configuration. Okay, let's see. Here you see basically how they place the supporting bars to these bent up bars. Okay, these are these blue color bars are supporting bars to the those bent up portion, those in bent up portion. Okay, and if I show you in cross section, let me show you. Yes, this one. You see this bar. Okay, this one, let me, this one. Okay, this bar, these are supporting bars which is provided to the bent up bars. Okay, so the in video you seeing here that blue bars. Okay, and the next one is the red bars, both in both direction. You see in top of the slab and in bottom side of the slab. You see these are the torsional reinforcement and they are provided both side by L, the maximum larger side, divided by 5. Okay, and you see clearly. Okay, so this is your torsional reinforcement, but torsional reinforcement is optional. It is provided only in the case when your edges are simply supported. The beam, the slab edges are simply supported, remember. And when you have beams or columns, we do not provide that torsional reinforcement. Let me show you another video. You see here one bar is straight, the other bar is bent up. Okay, but the most important thing which I already explained, that you see the one side of the bar is bent up, the other side is straight. Now the next adjacent bar, the opposite side edge of that bar is bent up while the other end, this is called alternate bent up bars. But in this video you see that one bar is basically straight, the other bar, two sides, both sides are bent up. But here you see one is straight, one edge is straight, the other edge is bent up. So this is the configuration. You must understand the configuration, that how basically you see here clear straight, but the other edge of this bar is bent up, but the adjacent bar edge to that side is straight, but here is bent up. Okay, so this is how we can provide basically bent up bars. Okay, and here are columns, so therefore beams, so therefore they do not provide any torsional reinforcement, remember. So, and remember two sides bent up bars. Okay, so this is very important to understand, that how we can basically provide the bent up bars. Okay, so you must understand this. Okay, so let us see. Here you see basically this section at AA. Okay, I cut the section at panel A. Okay, so if I am looking to this panel in this direction, you see that this is my shorter direction, this is my longer direction. So my main bars will be along the shorter span. So here you see this is my main bar. Okay, which is just provided at the bottom. Okay, this is my main bar, and twiddly hook is provided. Okay, and the above bars are also my main bar, but they are along the longer side. Okay, in two-way slab system you can't say that this is my main bar and this is my this is my distribution bar. Okay, because both bars in both way basically they are taking loads. So the above circular portion which you see here, this one, these are my also main bar, bottom main bar, but they are along the longer side. And here you see basically these are just supporting bar number 4 at the rate of 11 inch center to center both way. Now you see the bent up bars. Okay, so these are alternate bent up bars. Okay, for example, if I show you that this is my slab system. So the one bar should be straight, its end should be bent up. Now the next bar is straight, but they are bent here, and similarly so on. The arrangement should be look like in this. So this is called alternate bending bars. Now here basically I draw the complete section with okay, here you see slab detailing. Okay, so I cut the section basically, you see the whole, here you see the whole, basically the whole panel is now cut up, and this is sectional BV. So here my panel A, C, 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 and again panel A. Remember that this is my shorter side and this is my longer side. So here the bars along the longer sides is on the shorter side bars. So make sure your bars which is provided along the longer side should be looks like in this way. Here you see the circles are just below the longer bars, because they are provided along in panel A basically. In panel C basically that is a square panel, so you can't provide that kind of arrangement. You can provide basically the bars in both way direction, because movement loading is same either in LA direction or LB direction. You see the bent up bar position, remember. So at the edge of the panel A you see the bar is bent up, okay, alternate bending up bar, and when they are reaching to beam at the end of panel A, basically at the end of panel A, let me show you where is my diagram here. This is my discontinuous edge. So here the bar is basically bent up, they move straight, and when they reaches to this beam basically, which is my beam, here they are again bent up. But remember, at the junction of panel A, where the beam is provided, the displacement or the spacing of the bars is 8 in center to center. Remember, this is in design. Okay, this is in design. So the spacing is provided is 8 in center to center. But yeah, this is, you see here, 8 in center to center. Okay, so that's why you see here that 8 in center to center. Clear? 8 in center to center. Here as well as here. And the rest of the all bars spacing is 11 in center to center. Only at the first support you see here at the junction of panel A and C, these top bars spacing is 8 in center to center. Now, very important thing which I want to discuss with you, that here you see the spans and the beams, and you see the bars from the face of this first interior support is basically bent up for extended to a distance of L by 3 and L by 3. Now this bent up bar from the face of this support is at a distance of L by 4. Remember, here are the coefficients. These are the coefficients. Let me rotate. Okay, you see from the first interior support the bent up position is L1 by 4. Remember, this is very important. Okay, and the top bar which is straight basically. Now here is very important discussion, okay, which is very important, that the bar which is bent up from that side is basically extended for a distance of L by 3. So this is important. Okay, this is alternating of bars. Okay, so here you have option basically that you basically bend up the bar at a distance of Ln by 3. Okay, one bar straight, one bar is bent up, one bar straight, one bar is bent up. Okay, so this is the way basically, okay, that you providing this bar, basically this bar is bent up, again it bent up, okay, again it bent up. So this kind of arrangement is a little bit a difficult way. So here if you are providing bent up bar, provide this as a straight bar. So different arrangement is possible. I mean, okay, different arrangement is possible. Now you see, this is the lab zone, this is the lab zone. Here you can provide lab zone, here you can provide lab zone. Okay. Now the way I basically provide the lapping, here you see, because the lapping should be in alternate manner. Okay, so this is my bar which is just straight, you see, and I provide lap here. Okay, because 19 plus 18 roundabout it reaches to 40, because the length of the one bar is 40 feet available in market. So that's why I provide lap here. Then again I provide lap here, and the rest of the bar is this one. This is my straight bar. Now the bent up bar, basically you see here, this bar is basically bent up coming down, and here I lap here. Okay, I lap the bar. Now this is important. Okay, and then again you see the straight up bar. Okay, but if it is coming from this direction, it is bent up. Okay, and again it will basically here you lap them, but they are in this pattern. Okay, bent up in this way. And then again you see the bar is basically, when you lap them, the bar is again bent up, okay, and reaches to this point. Similarly, the next bar is basically bent up straight, okay. The next bar is basically straight, okay, and they are bent. Remember, in first position they are bent here, and now they are bent here. So here we alternate the bar. Now the other difficulty is that at first interior support we have number of bars at the rate of 8 in center to center. Now, so how to maintain that spacing? You see, this is straight bar and this is my bent up bar. So if you are providing alternate benting up bar, so how to maintain that 8-inch spacing? This is important, okay, because it's difficult. So for that purpose we have to provide extra bars. Now if I am providing extra bars, okay, because if I alternating the bars, for example, if I am alternating the bars right at this point, so if it is my bar and I bend it, okay, and then coming down, okay, and then it is my straight bar which is going in downward direction at the bottom, then I have to again bar the bent up. Now you see the difficulty that the spacing between these two successive bar is 11 inch and this one is 11 inch. So at the top basically this spacing will become 22 inches. So that why I have to maintain 8 inch center to center distance. So how to maintain? I have to place basically extra bars, okay, to produce basically 8 inch center. So because this is my top bar which is bent up, then if I provide extra bar, okay, and then I have to provide extra bar other bar as well, okay, because here you see 22 inches is basically the spacing in between the two top bars. So 22 I place two extra bar. So that why you see here now what will be the spacing, this spacing, clear? Now these are my top bars. So 22 is basically now divided into 3 parts, clear? 1, 2, 3 into 3 spacing. So this is my 7 point something, okay, 7 point something. So this is the way how you can adjust that 8 inch center to center. This is not actually then 8 inch, but it is 7 point something, clear? And one thing which is very important to basically to offset this difficulty, because practically it is very difficult for the labor, okay. So the best approach is that you provide uniform spacing, and here you see the best option, use number 4 at the rate of 8 inch center to center all over the slab for uniform spacing. This is the best option, okay. You provide 8 inch spacing to all bars. So that why if you keeping one bar straight and the other bar is bent up, then again one is straight, the other bar is bent up, so you will maintain the spacing that is 16 inch, so you need one extra bar, okay. If you are using 8 inch center to center, so you see if this is my straight bar, okay, this is my straight bar, then for example this is my bent up bar which bend here, which will be bent here. Now you see the spacing between these two bars is now 8 inch. The spacing in these two bars is now 8 inch. But this is my bottom, and this is my top. Here is my top bar. Now again, if I place a straight bar, then I have to place top bar, or you can say bent up bar. Okay, now these two is my top bar in this region. So the spacing in between these two now 16 inch, because 8 inch is the successive spacing, so this is my 16 inch. Okay, now we have to place one extra bar. Okay, we have to place one extra bar, so that's why at the top we will gain the required spacing. Okay, so this is the explanation that how you can provide such kind of arrangement basically, and how you can maintain basically the uniform spacing. Okay, so I think you understand and you got the concept how to place bars in two-way slab system. Clear? And how to provide lapping and how to alternate lapping. Clear? So this is very important video on detailing of the slab, because this is you must understand. Okay, you must understand. And instead of these kind of arrangement, you have to provide torsion reinforcement. Okay, right here as you see in video. Okay, at each end you have to provide torsional reinforcement. Okay, at this corner, similarly at this corner, at this corner. Okay, at this corner, at this corner, at this corner, here, 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 here and here. Okay, so these are my, here I need torsion, but remember, if I provide an L beam here, if I provide column, if I provide beam here, so I don't need any torsional reinforcement. Okay, but if they are simply supported, then we provide such kind of torsional reinforcement. So this is related, this video is basically related with the with detailing of bars. Okay, now in next video inshallah, this basically this lecture winds up here to the detailing of the slab, and next lecture inshallah we will discuss the design of the beam, and we will discuss these coefficients as well, how to select these, how to use these coefficients. I already explained these coefficients in my channel. Okay, for example, if you search my channel, you go to my channel. Okay, and here you see that basically if you go to my channel, okay, and here you can see the playlist. Okay, in playlist basically you see this project. Okay, this is the two-way slab project, and here basically you can see in this video, like in lecture number 4.2 something. Okay, here I also explain the whole bent up bars, the detailing of this slab system, and basically the torsional reinforcement and these coefficients in very detail. Okay, so you can either watch there. Okay, it is very informative lectures these are. Okay, and one thing more, that you have to watch the detailing of reinforcement in this lecture, in this playlist, basically the development length, how to hook the bars. Okay, and other thing, the theoretical cut-off points and actual cut-off points. You will understand what is theoretical cut-off point and what is actual cut-off point. And similarly, you see all these videos and the detailing of steel. Basically, I have do some kind of examples on it, how to detail. Okay, and the T-beam design, and how to use the graphs to provide bent up bars. Because remember that if you are bending the bars, basically, so if you are bending the bars, like here you see these coefficients, there are some kind of you see these are approximate coefficients, and there are some constraints. Remember, the constraints are that your load should be uniformly distributed, your spans should be nearly equal. Okay, if you have point loads, if you have non-uniform loading, then these coefficients do not work, remember. So then in that case you have to calculate actual cut-up points, actual these bent up points and these bent up bars. So for that purpose you need basically calculations, and I basically explain here those calculations, that how basically you have to provide basically those bent up bars using different graphs, using mathematical works, okay, and in very detail, basically in very detail. You see basically this kind of bars, this kind of table I will use here as well, but it is very important, and the T-beam design basically, it is very important, okay. So you see this graph is provided in the end of lesson book, and how we use this bar to provide these bent up bars. Very important lecture, inshallah, next coming lectures, okay. So this winds up basically, and if you have any question, any suggestions, please share your suggestions.